Começar, boa tarde a todos, né? Já vamos começar. Mas antes de começar, aqui tem um aviso para vocês não esquecerem de fazer o check-in para obter os certificados depois, tá? Então, lembre de fazer isso. Pessoal, antes de começar, vamos fazer em inglês, devido ao professor Miroslav, ok? So, good morning, everyone. Good afternoon, everyone. My name is Ciro. I'm the chair of this session. I'm professor here at ufsc-bnu. The subject of this session is electric mobility in the context of Smart City 5.0, paving the way for sustainable urban transportation. So, thank you all for being here today. On behalf of the conference coordination team, I would like to thank the presence of Professor Miroslav from Czech Technical University in Prague, Czech Republic, Professor Mauricio Uriona from ufsc-Florianópolis. Okay, thank you, Professor. And Dr. Lívia Benvenutti from ufsc-Florianópolis also. Okay. Here, so Professor, we can start with your lecture. So let me introduce first. In this first stage of this session, we have two lectures. The first one is from Professor Miroslav, and the second one is from Professor Mauricio Uriona. And then we will have time for questions and comments after those presentations, okay? So please write down any comment or questions that you may have to ask, to share with us later, okay? Então, so firstly, invite Professor Miroslav to present his lecture. Professor.
Dear Chairman, thank you very much for invitation. I'm really happy that I'm again in Latin America because it's my hobby. I visited 17 times Colombia and for the second time now in Brazil. So I started to learn Spanish, so maybe now I will be interested more in Portuguese language or Brazilian language, and it will be my pleasure to be better in this area. So, as was mentioned, I am from Czech Technical University in Prague. CTU is very old university, established 1707, so we celebrated 310 years of our existence. We have roughly 20,000 students and 8 faculties like colleges. So I used to be Dean of Faculty of Transportation Sciences for 2 voting period, and we have similar rules like American president 2 times and no more. So now I'm Vice Dean for external things. So between years 2018 and 2022, I used to be visiting professor at Texas University at El Paso, and I taught there the Smart City Fundamentals course. So it is the map of Europe, and you can see that the Czech Republic is in the center. So we are in the center of Europe, and our capital is Prague. And if you look at Prague, so you can see a lot of bridges. And bridge is for me the symbol for cooperation. And I tried in my history cooperate with America, United States, but also with Latin America, and we created EATIS Association. It is Association for Cooperation between Latin America and Europe in telematics and informatics. As I mentioned, CTU, that it is very old university, and also we have, as a part of our university, Czech Institute of Informatics, Robotics and Cybernetics. It is a relatively new institute that is well connected to German industry, and when our institute was open, Angela Merkel, former German Prime Minister, visited us, and last year we had there also German President. So we are a laboratory that is very closely connected to German university and to German industry that is leading in Europe. So, as I introduced Institute of Informatics, Robotics and Cybernetics, so our Czech way how we understood smart city is through Industry 4.0. We now living in era of fourth industrial revolution. First one is featured by using power, second one by electricity, third one using by computers and automation technologies, and now the fourth industrial revolution means that everything is connected, like we are connected through networks, social networks, also in industrial process, all components, product and material and transportation means are connected, communicate, and can negotiate each other and find the best solution. So the result of Industry 4.0 is a massive individualized production. So in past it was nonsense, because in China we had a lot of production by unified product, but really due to fourth industrial revolution and due to Industry 4.0, we are able to customize every product and also guarantee massive production. So it is approach Germany into industrial process. I know personally professors from Germany who invented this approach to industry 2011, and we closely cooperate with them. If I look at smart city, I understand it like optimization task that we have inhabitants with commercial, public and leisure activities, and we would like to provide services to different kind and group of citizens, but with minimized resources like land, energy, and as was mentioned here, and also with maximal use of existing infrastructure. Because in Europe, especially in Prague, it is a historical city, there is no possible to build new infrastructure. So we must use new technologies to maximally use existing infrastructure and be sustainable and to be resilient. There was mentioned many times sustainability. It is important to say that sustainability has three pillars. First one is environmental. Everybody speaks about environmental protection, but very important is the social and cultural pillar of sustainability, because you can have a very good environmental oriented city, but if you have some tension between a group of people and inhabitants, so the city is not sustainable. And third one is economical. If you will have a nice city with a lot of good people, but if there will be no jobs for people, so the city is also not sustainable. And it is important to have in mind that all these three pillars must be taken into account, not only the first one, but also the social and economical pillars. Now, after the COVID, is very well discussed parameter resiliency. There is a difference between resistance and resiliency. If the system is resilient, even if there are some problems, the system is able to return to initial state in a sustainable way. If the system is resistant, they are protected against some changes, but then collapse. So resiliency is well discussed, and urban resiliency is a well-studied subject, especially in the United States, and it covers security, cybersecurity, climate change, disaster management, risk management, critical infrastructure, and all things that were here presented. Our approach to smart city is this definition. We have also publications. We speak about smart city 5.0 and smart, sustainable, and resilient city is a new vision of city as a digital platform and ecosystem of smart services where agents of people, things, documents, robots, and other entities can directly negotiate with each other on resource demand principles, providing the best possible solution. So I can imagine that we have resources, limited resources, we have some demands by and in virtual space, there can be some negotiation of software agents that represent different part of this of the city. So it was a short introduction into smart city, and now the topic of this conference and also my presentation is smart energy. If you look at energy, so you can see that roughly a third is spent in industry, other 40% in buildings, and other 28% in transportation. So this curve is interesting because it is the urban density and it is the energy spent for transportation. So you can see that it is United States, that the cities are not so dense and they spend a lot of money and a lot of energy. It is the Australia, it is the Europe, and it is some Tokyo and Singapore, some Asian cities. So you can see that there is it is the similar graph that solving the energy means, or speak about smart energy, means also three pillars. First one is alternative smart energy sources like solar panels and geothermal energy. Second is a smart grid energy distribution. It is a smart grid, how to distribute the energy. And the third one is a smart load energy utilization, how control the energy consumption in your houses and in other applicants. Smart energy technology. So it is, I think, the well-developed areas. You can see using blockchain for energy, renewable energy, big data, storage, batteries, smart meters, market microgrids. Batteries are well discussed that there is every week in some journal some information about new kind of batteries and new principles of batteries. It is interesting technology. It is transparent solar cells that you can use it as a window and go through it, and it is a solar panel, and new buildings are now well designed by this technology. It is the technology of Tesla that you can use solar panels on the roof. It is from Siemens combination wind energy with solar panels. It is like a smart flower that can change and find the best position for sun and to maximize the energy. It is the picture I made in Berlin, because every big city, and it is for me a message to Brazilian cities, has something like a living laboratory, some part and some district of the city for testing new technologies. And it is not only technological testing, but it is testing of reaction of people, how people accept or not accept the solution. And I have a very nice cooperation with a technical university in Berlin, and in Berlin is EUREF area. It is a brownfield where are more than 100 spin-off companies and technical university and big big companies like Schneider Electric and Siemens, and together they do some research and development of new technology. It is the combination of solar panels and electric charging stations. And it is like a university or that you can have pay for tour, and every component in AWF is very well described, and students can go through this living laboratory and see under real conditions different technology. This is also from AWF that it is smart street lights, combining street lights and electrical car charging. It is other street lights. So electromobility is not new. So I prepare for you this picture. So it is here 2016. If you look at the scooter, so it is really same as now. So it's with older technologies. So the first electrical car was developed 1886. So there are some description how this was developed, that in the year 1900, 1/3 of vehicles on the road were electric. But in 1920, the situation was changed because the fuel was cheaper, and there was winner between electrical cars and fuel cars. But history is repeated, because in Czech we have a very famous inventor, František Šližík, who invented this electrical car and tested it 1895. And when I used to be dean of faculty, so I had a present from Škoda car. It is the Czech car industry, and it was the historically first electrical cars produced by this car industry. So you can see that to history and to now, so the electromobility of electric cars is not new, but there is now better time for understanding why they can be used. I understand electromobility not only passengers cars, but in broader sense, trolley buses, trams, and others. Electromobility has a minimal local pollution, because it's not only CO2 and O2, but there are also nanoparticles and other very harmful pollutants. And if you look at the development, so every year the batteries are 5 to 7% cheaper, and the capacity is 5 to 7% higher. So we expect that 2025 the electrical cars can be very economical advantages comparing with traditional cars. And also there are some subsidies from government, and in Prague we have, for example, free of charge parking for electrical vehicles, and it is big benefit because the parking is a big problem, and there are lack of parking places, and electrical cars has advantage that can park. And of course this new industry created different approaches. There are standard open charge point protocols, and you can connect different charging stations, and you can speak about local charging and some dynamic charging according to preferences and according some priorities, and so on and so on. And it is very nice to see the development not only electrical cars, but on infrastructure for electrical cars. And electrical cars can be produced in the future by car industry or by strong partners, but infrastructure components, it is the chance for local industry in different countries. As I mentioned, I will not speak about electrical passengers cars, but I will show you some example of public buses or public transport. So if you compare traditional bus and e-bus, you can see that there is comparison of CO2 and NOx and SO2. But what is important, and I think the most important from the health care point of view, it is nanoparticles, 2.5 and 10. And if you compare traditional buses and electrical buses, you can see the enormous difference. And I believe in application and using electrical buses in big cities like Sao Paulo, or Rio de Janeiro, or Prague, because really there are such benefits. I have a few slides. I will go fast. So it is the traditional electrical bus for charging. If you look at the bus, so they have a pantograph like trams, and the pantograph can be used and charge the electrical bus. It is the second solution. Or there is also up-charge, that you have this pantograph as a part of infrastructure, and bus go and ask for electricity, and the pantograph go down, and there are some advantages, disadvantages. It is the solution very well discussed in the United States, and a lot of universities work on it. It is the inductive charging, that you will have some inductance and some components inside the infrastructure, and the bus go and charge it, and of course using solar panels. So there are many technologies. We will see what will be the best. There are some advantages, disadvantages. You can look at the presentation. It will be available for you, and compare advantages and disadvantages. There are some European projects. It is example from Göteborg, from Ostrava, Czech Republic, from Warsaw, Slovakia, Barcelona, Spain. There are only examples. Of course, other electrical public transport means is a tram. It is very famous in Prague. And it is part of our life, and we like trams, and it is electrical transport means. Other, very historically, we had in Prague trolleybuses, and now the trolleybus returned back to Prague. Some cities still in past use trolleybuses, metro, and train. Of course, electrical train. You can see the pantograph. And other electrical transport means, it means some scooters, but also some machines for cleaning the snow in Europe, or cleaning streets, and make waste management and something like that. Charge, I have for you, I will go only very fast, 2 case studies. First one is the charging infrastructure of electromobility. So in Europe and in the world seems to be more popular alternative current than direct current. You can have a comparison of these two approaches. We were invited to do the study for city Kladno. Kladno is 40 kilometer or 30 kilometer out of Prague. It is industrial city, and the question was to localize future charging stations. So we did first analysis of optical infrastructure, because it's necessary to have communication infrastructure, electric infrastructure. It is very important to have enough electricity and to have good infrastructure. And then we divided the requirements into 3 areas. First one is that you need your charging 20 meters. It is typically in shopping centers. And people are don't want to go longer distance for charging cars. There is 300 meters and 500 meters. It is the typical for inhabitants in some district. And if you look at this requirements and take it together. So the result was that we had estimation of the best location of charging station for passenger cars for inhabitants that would like to have electric cars, but for shopping centers and also for commercial use. And there exist a lot of applications how to find the best charging position place in Europe to make a booking of your charging. So it is one example from Belgium. Second case study is very quickly is electrical bus. So there was the requirements to design a line of electrical bus. So there is some modeling. It is the time and it is bus speed. It is time and it is line attitude. So of the geographical profile of these buses. And it is the similar graph with distance in kilometers. It is also bus speed per, and on the x-axis it is distance, and it is attitude and distance, and it is the charging point, first one, and second charging point. So there was some processing of the data based on this simulation. You can see total traction energy that is possible, and the result is that you must have 10% reserve, and you don't want to have a battery 100% full, so you have this at disposal, and you can see the energy discharge and energy reserve, and in this place and in this position there is charging the battery, and bus can continue of this part. So very quickly to hydrogen, because hydrogen is very popular in Germany now. Toyota has the first commercial available car for hydrogen, Mirai. And hydrogen, if you look inside, it is plus minus electrical cars, because you have a hydrogen that change hydrogen into electrical energy, and there is also a small battery that is for some balancing the energy. So I understand that hydrogen's alternative batteries or are the part of electromobility and are well suited not for passenger cars, not for buses, but for trains and for lorries, like it is here. So it is the world first hydrogen-powered smart tram to run in Malaysia, and it is from Germany that is in commercial operation, the hydrogen train on the regional parts. And if you look at Europe, so you can see that Germany is full of fueling station of hydrogen. In Czech we have now 2, but there is the plan to increase in France, in Spain, in England. You can see that this map will be more and more full of hydrogen station. Smart grids, very quickly, it is the development of energy measuring equipment, and current energy equipments are both sides and can collect information from your house. And a smart grid means that there is an energy network and information network, so information components. And every node of smart grid has a source of energy. You can have solar panels, you have appliances like your refrigerator and your cars, but you have also storage, because you can have a battery in your house. And all these 3 parts are part of node of smart grids, and it enables that with help of intelligence you can share the energy in a time the energy is low. You can buy the energy and store your battery, and in time the energy is expensive. You don't buy the energy from operator, but you use your energy from your battery. So it is the collection of all customers, industry, street lighting, factory, and balancing between them, because every building and every component of a smart grid has different requirements for energy consumption. For example, school is very active during the day, but the residential building in the evening and so on. And they can, if you know the requirements and you use the prediction algorithms and machine learning, you can very well make a forecast of energy. And then if you have a good forecast, so you can have a lower energy. So it is the example of a house that you have energy interfaces, you have gas interfaces, and you have internet interfaces. There is a local energy source. It is like a battery. 5 is a storage. It is solar panels. It's 4. It is battery, and 7 are appliances, and 5 is 6 is electrical vehicles charges. So you can have 2 and more electrical vehicles. And if you look on some model example, so it is the price of energy that during night is low, but at 6 p.m. is very high. So your energy flow to appliances is that you return from work, so it's in the evening, and then the system try to use energy storage content to balance some differences between price of energy and make your system the more efficient. So it was some illustrative example, and it is example of professional software from Schneider Electric. It is the French company. I have here. And if you take this principle of smart grid not only to house, I explained, but to city district, you can see this example of city Boston. So it was done in Boston.
Simulation engine for this research is Energy Plus, a thermal modeling This example looks at July 7th, the hottest day of the year recorded in Boston's weather file. The multicolored surface represents the hourly electricity demand, and the graph on the right displays the total profile of the city. At night, pictured here, electricity demand profiles are at their lowest. At 7 a.m., most buildings have started their daily operation cycle, and the profile shows a clear demand concentration in the denser urban areas including downtown, Back Bay, and South Boston, where most commercial buildings are located. Since these morning demands are caused primarily by lighting and plug load, residential areas retain moderate consumption rates. In the afternoon, solar gains have increased indoor temperatures. As residents begin their return home, air conditioning becomes a significant residential load, raising the overall electricity demand of the city. A peak is reached between 5 and 6 p.m. Commercial demands start to drop through the end of the weekend. At around 9 to 10 p.m., residential air conditioning use also begins to decrease. Lastly, minimum electricity demands are reached around midnight. By understanding the urban energy use patterns in each location throughout the day, the city can develop targeted energy policies and building retrofit strategies to reduce building energy use and alleviate the burden on high-demand portions of the city's electrical grid. To understand how this model can be applied, let's take a closer look at the Back Bay, Columbus, and South End neighborhoods. The graph on the left shows the hourly electricity demand for this particular section of the city. Commercial buildings are responsible for most of the demand, which peaks between 4 and 6 p.m. In this area, there is also a high concentration of buildings with a relatively uniform roof height. Installing solar photovoltaic or PV panels on these roofs has the potential to reduce the electricity demand covered by the grid. Let's consider a scenario in which 50% of the roofs in the area have PV panels. Using readily available simulation tools, the city can predict the energy generated by those panels according to their context. How would this affect the demand profile for the area? The results of the Boston energy model help answer this question by clarifying which buildings and uses are responsible for the demand. Commercial buildings such as offices, retail shops, and hotels are responsible for most of the consumption throughout the day. At critical peak hours, however, residential buildings increase the demand even further. A large part of that peak comes from cooling requirements in all building types, which is unavoidable during the summer season. Let's now include the PV panel production in the hourly demand profile. Although the grid-based electricity supply would be smaller overall, a larger disparity between base and peak loads emerges in the afternoon.
So you can see that what I explained for house, one building was done in Boston for whole area and for whole city, that they identified the consumption of residential buildings and commercial buildings and universities and hospitals and so on, and prepare this solution. And if you can measure and you understand your consumption, you can then find a solution like solar panels or other areas. So very quickly, autonomous mobility. So it is future, because now I cannot imagine autonomous cars or bus that is not on electrical consumption. So it is other video. It is a bus in Sion in Switzerland, and it is fully autonomous bus under a real city condition. So you can see that there is the other traffic, and this bus is operated there. There is a Hyperloop. It is a SkyTram in Israel. It is the project. It is the Skyway. I included this new transport technology that, in my opinion, it is very suited for Latin America countries like Colombia. For example, in Bogota, they speak about metro, and such kind of transportation is much cheaper and very efficient, and it is autonomous. So you can find a lot of videos how it works, and also in some Arabic countries it is under construction, and infrastructure is not so expensive, and you have very big roads in such cities, and it can be on the first level of mobility and transportation. And in my opinion, it's most efficient than metro or such a very huge infrastructure system. So we have not time to go through it. It is autonomous drone that was tested in New York for passengers, and autonomous tractor, maybe also some chance for future agriculture in Latin America and some countries who are very active in agriculture, that they can use autonomous tractors and autonomous systems, because such system can work also during the night and can have not need a driver, and they are not dependent on human factors. So very quickly, mobility as a service, it was here mentioned that in the future there is expected that you will have agreement with mobility operator like you have now with telecommunication operator, and this mobility contract will guarantee you taxi and public transport and such services. It is from some European material that I have a mobility operator and I have this package, 95 euro per month, and it guarantees me such kind of services. And the system is automated and try to connect all mobile transportation operator, private, public transport taxis, and to provide you best tailor-made services. And it is the return to Industry 4.0 that we try to find a way using smart technology to provide individualized services for different category of citizens in the system. So I am going to conclusion. It is invitation to our 10 years Prague Smart City Symposium, Prague. So it will be next May. So the students and professors are welcome to send paper, and it is the part of Scopus and IEEE. So Smart City is in our faculty very popular, and we have a double degree with the Texas University at El Paso, and they are our first students who graduated Smart Cities and received both American and Czech title. It is the typical American commencement. This cooperation with the Taiwan universities that would like to cooperate with us in PhD study programs, and they are very good in informatics and building digital twin of cities. So thank you very much for your attention.
Okay, thank you, Professor, for your valuable time and insights. Now, after in the end of the session, we will give some time for questions and comments. Thank you, Professor. Now I invite Professor Mauricio for his letter. Please, Mauricio.
Okay, hello everyone. Thank you for this second session. My name is Mauricio. I work at ufsc Florianopolis at the Synergia Renewable Energy Lab. It's a pleasure being here, talk to you about some advances that we've seen in electric mobility. Here at ufsc Blumenau, it's part of our family, I would say. We've been here many times. It's really wonderful being here, talking about something that we are very passionate about. So at Synergia Renewable Energy Lab, we're also interested in looking at all of these new technologies that are emerging. Today we're going to talk a little bit about electric vehicles, but we're also interested in the interconnections between these technologies and other renewable energy technologies from a particular point of view, which is the economics view. And I, as many of you, I suppose, I have a background in engineering. When I started studying renewable energies and electric vehicles, my question was, wow, this is wonderful. So if this is such a great thing for everyone, why is it not possible for every one of us have a Tesla, for instance? So in this morning, my colleague, Professor Lucila, was speaking about her desire to own a Tesla in the coming future. And I suppose many of us would like to have solar panels on our houses or an electric vehicles on our garages. And we started noticing that one of the main things that, and perhaps the most important thing that those things that doesn't happen yet is because the economics. So moving away from my engineering background, I started getting more interested into the economic side. So Professor Selene, I know she has a course here in economics. I encourage you all to learn everything about it, because basically everything we do in our lives, from the moment that we wake up and we decide which breakfast are we going to have, or from the moment that we decide if we're going to get an electric car or not, is going to be based on the economics. So I'm going to give you guys a different perspective from my past colleagues. I think I'm very grateful for Professor Svítek's last speech. He gave us a lot of very insightful notions of what an electric grid is, what smart grids are, what electric mobility means. And so it will be easier for me to speak about some of the specifics that Professor Svítek and my colleagues this morning addressed or covered on a more technological side, I would say. So today we're going to talk a little bit about what's the current status of EVs. We're going to look a little bit about Brazil, but we're going to speak also about elsewhere. We're going to talk also about the challenges and potential solutions. We're going to look at the EV markets, and there's a lot of economics in here as well. And finally, as Professor Svítek mentioned, one of the gold areas in the near future is how are we going to use hydrogen, and basically green hydrogen, to power up not just vehicles, but basically every kind of electric appliance that we have. So let's just first have a very quick overview on what EVs are. There are basically, I would say, two main types of EVs that we've known so far. One of them are the battery electric vehicles, which is a type of vehicle, the one that you see that you plug in an electric appliance, and then you just charge your car. Then we have a second type, which is the PHEVs, are called plug-in hybrids, because you can also charge these cars with electricity, but you can also use gasoline. And a third type, which most of the time we used to forget when we talk about EVs, is what we call the fuel cell electric vehicles, which are what Professor Svítek mentioned before, are hydrogen-powered vehicles. And we used to forget about these vehicles because the economics on the hydrogen side were very high. It was very, very costly to have these vehicles, even to manufacture these vehicles, let alone to buy one of those vehicles. But as I'm going to show you in my last slides, you're going to see that the economics are coming down, and very, very fast, by the way, and we're going to have, perhaps in the near future, a more promising prospect for these kind of vehicles as well. So why are we interested in EVs? And there's a lot of advantages that my colleagues mentioned before, but I would really like to point out about the SDGs, the Sustainable Development Goals. I know there's professors in environmental sciences here as well. It's also an environmental engineering. It's also important for you guys to do those courses as well. But basically, the SDGs tells us that all of us as a society have to think about common solutions. And all of us as different countries, as we have rich countries or poor countries, all of us have to work together into the same types of goals. And when we speak about EVs, you can see here we have a lot of those goals somehow being attained. So for instance, we're talking about clean energy. It doesn't really make sense to have a full electromobility in your city or your country if you don't have a lot of renewable energy powering on those vehicles. You also need to have innovations and infrastructure. I'm going to talk a little bit about EVs infrastructure as well. We need to have sustainable cities, which is one of the main topics in this conference. We also need to have responsible consumption, and it also has to do with, for instance, what we do with batteries with these cars. Once, at least as we know, one of these batteries can have maybe 8 years or so of life. So you need to dispose those batteries before. And finally, climate action, which somehow was addressed by Professor Tiziano this morning. So we see that many of these goals are somehow touched when we speak about EVs. And if we put all of this together, one of the big name of this presentation will be how to decarbonize the economy. One of the biggest players then will be the transport sector. And if we look at EVs as the main silver bullet within the transport sector, we're speaking about decarbonizing the economy. So what's the current status? A lot of my colleagues talk about this before me. I'm not going to go very deeply into these graphs, but I just wanted to show the last numbers from the IEA, which is the International Energy Agency. This is the latest data for the 2023 EV outlook. So we've seen basically that sales are spiking up. Each and every year, we're having more and more EVs being sold all around the world. Of course, there are some countries that are leading the way. So we have China, and we're going to talk a little bit why about China later on. We have Europe, we have the US, and we have the rest of the world. And the projections show that if we keep up this rate of growth, in maybe 5 or 10 years, we will reach parity in terms of the number of vehicles in our cities, in our countries, as compared to gasoline-powered vehicles. So there's a lot of hype in terms of how many EVs are being sold all around the world. In terms of mass market, and this is another key point when we talk about the economics, if you really want to get to a point where your product either be a car or could be a cell phone or could be a chair, if you really want to get mass adoption for this particular item, for this particular product, marketing specialists and experts say that you should need maybe around 20% up to 40% of market so that you can actually say that you're leading the market. And in terms of EVs, if we compare and we take a bunch of different countries all around the world, and we see how many of these countries have how many EVs and how many gasoline-powered vehicles. We see that, for instance, in Norway, we have in 2022 around 80 or 90% of the whole vehicle fleet already as EVs. We see Sweden, which is very close to Norway, following the way. We see other important countries here as well. We see, for instance, USA, which is around maybe 10% of the whole fleet of passenger cars being EVs. 20% of total sales in China and other EU countries were EV in 2022. So that means that these numbers will change very quickly as well. In terms of emerging markets, and we'll start talking about Brazil here, and unfortunately there's not much to say about what's going on in Brazil, unless, of course, that the numbers keep growing as well. If we look at the national media, we see advertising on different car makers, Chinese car makers and Swedish car makers and so on, and German car makers in Brazil selling new cars, selling new EVs each year here in Brazil. But if we look at the emerging market side, actually Brazil is going pretty well if we compare it with other Latin American countries and other emerging economies as well. I'm going to show you, I think in the next slide, that Brazil reached about 55, somewhere between 50 or 55,000 EV sales in last year. Yeah, somewhere around 50, 55K. And this is Brazil. So these are the latest numbers that we have in Brazil. We see that 30%, 32%, around 1/3 of all the EV market sales comes from these two types that I mentioned before, which is the BEVs, purely electric, and these plug-in hybrids, the ones that also work with gasoline. The remainder, the 67% of remainders are hybrids. So for instance, if you've heard about the Toyota Prius, is one of the most famous hybrids. So it's not conventionally known as an EV car, but it does have some sort of like connection of recharging, for instance, an internal battery that the car has when you're using your brakes on your car, on your Toyota Prius. So technically it's not an EV car, but if we look at the Brazilian numbers, 67% of sales last year came from those purely hybrid types of cars. Those are, just gasoline powered maybe, but like I said before, they used regeneration energy from braking or some other types of use within an internal battery. We also see in Brazil that the numbers keep growing. Okay, so in terms of main challenges that the EV industry has, and I'm very glad actually that this, by the way, I prepared before this morning's presentation, but when I've seen Professor Tiziano's presentation, Professor Lucila's presentation, Professor Svítek, I was very glad that we have the same vision of what are the main challenges and what could be the main solutions. So I think that that's something very important if we're trying to look at how are we going to improve the EV market in the coming years, to know at least that we're on the same page. We're looking at the same problems, basically from the same side, trying to use different methodologies perhaps, but at least we know and we agree on what the problems are. So basically, I'm picking up four main challenges are important here. The first one, it's about range in terms of kilometers, in terms of distance. Electric vehicles, they have limited range. So if you are in a very large country like Brazil, it's not very easy for you to take your car, let's say from Blumenau to go all the way to São Paulo without needing to recharge your car maybe once or twice before getting there. What's the potential solution? And I'm going to speak a little bit about that later on with more detail. But basically, it's improving the battery performance. The second challenge is infrastructure. So even if you have a car with a lot of range, and some research shows that you'll have in the coming future cars with 1,000-kilometer range, which is a lot. But even if you have that, you need to have a good infrastructure coverage. The problem is that you need then to invest money. It's not sometimes a very profitable business. So in this sense of solutions, perhaps some PPAs, some public-private partnerships would be important within the government. The third one, and I think this we all can relate to, it's higher costs. It's very expensive to buy an EV. Even with the prices coming down, like my colleague said this morning, it's still very expensive to buy an EV car. What are the main or some of the solutions that other countries made? So they created different types of incentives. I'm going to show you a little bit about, for instance, the case of Norway, what Norway has been doing for the last maybe 10 years in the EV domain. A lot of different types of incentives. It also relates with the economics as well. And finally, the use of renewable sources. Like I said, you guys, if you don't have a clean energy matrix, at least clean enough, it wouldn't make much sense to have a lot of EVs going on and moving on your cities. The case for China, for instance, China has a very fossil fuel-based energy matrix. Like I said before, they are leading the EV market sales, but at what cost? If the energy that you're using to power up your EVs comes from fossil fuels, like the worst kind of fossil fuels, like carbon. Okay. So for the fourth challenge, potential solution will be to increase overall renewable installed capacity. So let's dive a little bit deeper on those solutions. The first one about range. There's even a name for that, which is range anxiety. Early consumer research on potential EV buyers identified that people was actually afraid of buying EV cars because they were afraid of being just in the middle of the road with no energy and with no charging infrastructure nearby. So it was actually a big fuss in the early years of the new, I would say, EV market, the 90s, 2000s on EV markets, where this range anxiety led to ever-increasing improvements in battery performance. So Toyota, for instance, is planning new EV cars. I think the name of Professor Zwick's car, it's the Lumina. I think he mentioned the one fueled by hydrogen. But basically, this is a race that most of EV car makers are going on. The idea is to make cheaper batteries. The cost of the battery pack is around 60% of the total cost of the EV car. So it's a big deal. If you have a big battery that has a lot of range so that you can move on for many, many, many kilometers, it means a lot of weight and a lot of cost adding up to your EV car. And by the way, let me just tell you that these numbers of these ever-growing numbers are shown basically on one specific type of passenger car, which is the SUVs. And actually, that was not the goal when people was thinking about adopting EV cars. The idea was to have very small cars, compact cars. The market thought otherwise. People started buying big, large cars. There's a lot of research going on that side. But basically, what people found out was that since the price of the EV car is so high, only people with a lot of money can afford these cars. And so these people that has a lot of money, they will prefer to buy a more expensive car. So that's why you have a lot of SUVs, EV types going on there. Maybe in Europe, in the USA, even more. And you see that many of the new models that are coming in are large cars. Okay. In terms of range, there's the graph showing how these pure battery electric vehicles are ranging around 350, 400. The numbers keep going up. The range keeps going up. And as you can see, the trend will remain very high as well. In terms of charging infrastructure, this is the other side I was mentioning before. There are some key things that I want to show you. So for instance, Tesla is one of the leading car makers in the world with EVs. They decided that they would create their own charging infrastructure. And they created two types of charging infrastructure. The regular one, which is that you see even here in Brazilian cities, you take your car, you plug it in, and you have to wait maybe 4 hours, 6 hours for the car to be fully charged. And they also created what they call the superchargers, are chargers with a lot of power that can actually charge your car in half an hour or so. So it's really fast. And if you think about this charging infrastructure, and if you have a supercharger that actually can do the job in 30 minutes or less, then it will be very easy for people to move around with their cars, even with lower range. That means a lower battery size, reducing prices of these cars as well, as long as they know where to charge their cars, and as long as they can do it very, very fast. So I agree, you must be thinking about, but wait a minute, Mauricio, 30 minutes is still a lot of time. It's not like 2 or 4 minutes that you wait to fuel your gasoline powered car. But it's still, it's technology that's improving. Charging a fully charged, or charging your car in 30 minutes, it's a big technology advancement. Globally, and these numbers come from the EIA, so they measured how many charging infrastructure there is in the world, how many EVs there is, and they created an average number. There is a ratio of 10 EVs per public charging globally. But of course, these numbers, they vary much depending on where you are. So for instance, in Korea, South Korea, they have one charging station for every 2 EVs. Whereas in the US, I think the number was around one charging station per 20 EVs. Let alone if we think about Brazil, I can think of the city where I live, Florianopolis. I can maybe count with my hands how many charging stations there are in the city. So there's a lot of difference between where you are, your infrastructure, who's going to take care of that, who's going to pay for those infrastructure, and economics tells us who's going to make money by letting you charge your car there. Okay. The third challenge, which is the cost. So there's a lot of information here. I'm not going to go over all of those. This data comes from Norway. By the way, Norway is the country, like I showed you before, that has over 80% of the total vehicle fleet as EVs. They did so with many, many different types of incentives. They looked at the consumer side, but they also looked at the production side. So in economics, you will say they looked at supply side policies, and they also looked at demand side policies. So for instance, like in Czech Republic, I just learned about, there are some incentives that you can park in places that were previously forbidden for gasoline-powered cars. You can park there. You can go inside downtown of these cities with your EVs in days or hours where gasoline-powered cars cannot. You also have reduced taxes, either for buying the car or either for your maintenance tax for every year, which here in Brazil, we call it IPVA. You also you are allowed to use bus lanes. So you have these lanes that only buses can go through. If you're driving your gasoline-powered vehicle, you will get a ticket if you go on that lane. But if you have an EV, you can use that one. You can also use specific lanes that are reserved, I should say, for cars with 3 or more people. So for instance, in California, there's a lot of cars there. There's a lot of traffic congestion there. So they have these specific lanes where you can only drive there if you have, I guess, 2 or more people, not mistaken, or 3 or more people in the car. If you're driving alone, which is basically 90% of people doing it, and if you're using this pool lane, then you'll get a ticket. But if you have an EV, you can use it. So there's, like I said, free parking and so on. So as you can see, there's a lot of policies, and that leads us to the question of who's in charge of making this transition. We have a multi-perspective. It's not just the municipal side or the state side or the federal side. It's also companies, perhaps universities, perhaps public-private partnerships. So there's a lot of these different relationships between these actors that need to be addressed if you really want to have a transition to these EVs. Norway did it very well. It's a very success story in terms of electric vehicle market, but they also have their problems. So at one point, for instance, there were so many EVs that was creating a problem with the local cities, with the governments. So they are actually turning down some of these policies because now the market is actually very mature. So for instance, the IPVA kind of policy, it actually wasn't working anymore because 80% of the cars are EVs. So basically no one was paying IPVA. So that was just crazy. And then the municipalities and the cities just started complaining, wait a minute, why do we have a tax that nobody's paying for? So they are actually winding down these policies in a very controlled manner so that population don't feel this pressure. They start adjusting their behavior to the new scenarios, right? The last challenge that I mentioned was renewable energy. My colleagues spoke about this topic as well. I think Brazil, in this particular challenge, is very well positioned. We have around 80%, more or less, of our installed capacity in terms of electricity coming from renewable energy. So that means that solar, wind, basically, and some other renewables, they account for basically 80% of our installed capacity. That's a lot of installed capacity. As opposed to the average of the world, where we actually have more than 50% coming from non-renewables. That means fossil fuels. I mentioned to you guys China. The US is on a very deep movement for decarbonizing its economy, but the US also has a very deep roots in fossil fuels. You have Europe that was used to power its residential sector coming from natural gas. Now with the war in Ukraine, with Russia, at least for the last 2 years, all of this supply chain of natural gas has been basically vanished. So they are looking for policies to even to renew some technologies that were actually winding down, like the nuclear technology. So it also comes with many different other topics here. I'm not going to go all of them. But basically, the idea is that if you don't have a pure or a very good share of renewables, then your EV market wouldn't make much sense at all. So how is the market for EVs? Numbers also keep changing. And I remember this morning, one question was, how can we make the price go lower? Economics tells us again that in order to do so, we need more competition. That means we need more car makers producing EVs. And in the world, we're seeing that. In fact, there are some numbers that show that the new models from even the traditional car makers that are fossil fueled, that means gasoline powered, they're actually coming down. So that means that less and less new models of gasoline powered cars are coming every year, as opposed to new models of EV cars, even from the traditional car makers, coming up every year. We see that Tesla, the American company, and BYD actually are the car maker leaders in terms of production and selling of cars. Tesla, it's a very interesting case. Tesla grew up basically based also on the economics. It was a time where California created a new policy called the Clean Energy Act, and included one of the first carbon credit markets in the US. So basically, the idea was that for every car, every fossil fuel car that you produced, you would need to buy some carbon credits, either from the government or from someone else. Tesla was starting developing their business model. They only produced EVs. They didn't produce any fossil fuels. So they actually started gaining a lot of carbon credit taxes from this market. And they were allowed to sell those carbon credits to the other car makers. So basically, there was a point that each Tesla that was produced was zero cost for Tesla. Because basically, all of the value of this car, all of the production cost, was coming from the carbon credits. Also, California implemented one of the first laws that would give a rebate on EV cars. And I think Professor Lucila, or I guess Professor Tiziano showed some numbers of how much each different country or state gives to buyers as a credit. So in California, I think the number was $7,500. So if you want to buy a Tesla in California, let's say the Tesla costs $7,500, so $7,500 will come out from a check from the government, from the California government. You will just pay the rest. So it was a very profitable business. Tesla grew up very, very fast with carbon credits as well. BYD, a different case. BYD was actually an electric motor company. They would produce electric motors, something like VEC that we have here, VEGI, right? They would produce electric motors for another whole bunch of industries. At one point, because China, there's a lot of involvement in terms of politics, of the direction of where companies need to invest. So at one point, China said, you guys need to start developing EV cars. BYD looked at the technology and said, wait a minute, this is the same electric motor that we use for wind energy. We just need to make it smaller and put it into a chassis. And then we can sell it as a car. And based on the Chinese incentives, which also I think Professor Tiziano showed, was like around $10,000, right, per car, then you have a spike, huge spike of EV sales in in China and a huge growth of BYD. In fact, here in Brazil, if any of you wants to buy a new EV car, the cheapest model of BYD, I think it's the Dolphin model, ranges around 149,000 reais, something like that. So it's like $30,000, $30,000, which is, yeah. So it's as opposed as 1 year ago, the cheapest model was like 2 times that price. Okay, so we see a lot of different other incumbents here, other companies that wants to compete in this market. So like I said in this morning, Volvo just reached a new model called the EC30. So this model is basically trying to compete against the Jeep Compass in terms of price. And each and every year we'll see new models coming in. So just to finish up here, guys, we're going to talk about a little bit about green hydrogen. And at one point, I would say that green hydrogen can become not only a promising support for the EV industry, but perhaps at one point, it would actually become one of the main competitors for the EV technologies. Because if you see green hydrogen in terms of price coming down so fast as it is right now, a lot of interest in Germany, like Professor Svítek said. We're also working with the German Fraunhofer. Germany, we're looking at the market in Europe for green hydrogen, and also the supply of green hydrogen coming from Brazil. There's a lot of applications for green hydrogen, especially for long-haul vehicles. So if you have like a logistics company and wants to use your trucks for moving around your merchandising all around your country, with a big country where downtime is very costly and you need your truck to be moving up all the time, hydrogen will be a better suit option as opposed to EVs. Okay, so the market for fuel cell electric vehicles is still very young. Surprise to me was to see that Korea actually has the largest share of fuel cell vehicles. And like I said before, Germany has a lot of projects. Big truck car makers are investing in R&D to produce fuel cell trucks. And so we'll see a lot of new developments probably in the coming years. Okay, so that's about it. I think I'm on my time. Thank you very much. We're open to questions.
Thank you, Professor Mauricio, for your detailed presentation. So now let's move on the discussions regarding both presentations. Dr. Lívia, you help me to mediate this stage of the session. So I encourage all of you to make some questions or share some comments about the presentations. Maybe you could do in Portuguese, we can translate it. Okay. Pessoal, podem fazer em português e daí qualquer coisa a gente traduz aqui.
So my question basically is, instead of electric vehicles, we focus more on another alternative like ethanol, that it pollutes less than petrol-moved cars and comes from agricultural byproduct, and doesn't create the need to change the whole fleet of vehicles to another source of energy like EV or hydrogen.
Anyone? Mauricio?
Yeah, Thank you. That's an excellent question. Actually, this morning ethanol was mentioned as well, as the new hybrids are coming in using ethanol. I'm not against ethanol. I think it's a great technology, but I think if we look again at the economics, if you look at a specific market like Brazil, maybe only a few markets will be able to develop these ethanol hybrid cars. And if you look at in the whole market chain, the whole world market, it will be very difficult for these cars actually to compete with price against the technology that will probably will be more broad, like EVs and the natural kind of sense. So I think that again the problem is economics, but I think it's a wonderful alternative to look at other possible solutions for the coming problem, which is trying to decarbonize our economy even more.
Thank you for the presentation. I would like to ask a question about China, and I liked a lot that you threw this view into economics. And what we see in economics is that China is trying to change our view about the country. That for many years was the copy country, like it was copying and copying and copying, and made in China became synonymous of low quality. And from years, from 10 or 15 years, it started to change into technology, trying to avoid the middle income trap that we unfortunately are into right now. And I think this is one of the sectors that it is putting a lot of money and effort on it. Do you think that in terms of technology, is it capable to compete? Because in terms of economics, I know that it's going to try to.
So I think that China started a huge development, and we did some study for German car industry 15 years ago about, for example, batteries, and we found that a lot of patents came from China. And if you look at patents, so the China is increasing number of know-how in batteries, and especially my topic is more smart city. And for example, Huawei or other companies are well developed, and only I think that Huawei has 3,000 or 4,000 researchers. And if you look at 5G networks or 6G networks, they are part of a smart city. So I think that China is very advanced. But on other side, so there are technological side and some application sides, and I am not fan of technology applied in China, especially in smart city, because it is not convenient if you cross the street and the system call for you your name that you have some black point from your government. So it is not our culture, but it is separate things. One is the technology, and our first president Václav Havel mentioned that the technology is morally independent. It depends on society how use it in a positive or negative way, and part of smart city topic is how to use the technology to increase the quality of life of citizens.
If I may just mention something about China, I think the difference now is that when China was trying to copycat gasoline-powered cars, the technology was very complex. It was actually one of the industries that the Chinese manufacturing industry couldn't get into because it was very complex. We're talking about 100,000 pieces a gasoline-powered car needs in order to be manufactured, as opposed to an electric vehicle, which is around 500 pieces. And they already knew the technology for building the electric motors, the electric engines with BYD, basically. So I think now it's a time where China is actually going to turn out the market and actually overthrow Tesla as well. Yeah.
Anyone?
we talk a lot about mobility in cities, and the electrification of cars doesn't solve a really big problem with infrastructure. Turning cars to electricity doesn't solve the difficulties with traffic and time delays to get to the places you want to go. So how does new EV technology can help us solve this issue? Because it's an issue not of the energy, but with the mode of transportation we use.
Yes, it is a good question, because if you replace all fuel cars by electric cars, you don't solve the problem. So, as I mentioned, I am many years active in the United States, and if you look at Los Angeles, so it is practically not usable. You cannot cross it by cars. It is 7 or 8 hours. So I believe in sharing cars, better public transport. So it was mentioned in my presentation that I concentrate and emphasize more electrical buses and try to avoid using passengers' cars, because the infrastructure has limits and you can not increase the limits by replacing fuel cars by electrical cars. And in cities like Prague, we have a problem with charging infrastructure, because if you have residential parts, so you have small flat, but you have not garage, and some solution is to use a street light infrastructure and so on, but it costs money and it will take time to build new infrastructure. So my recommendation is maximally use sharing economy, sharing cars, public transport, and try to use smart city technologies to better organize it and to offer individualized services that will be better and cheaper than using your passengers' cars.
Anyone?
I wanted to ask if you think that the changes, like when you're updating the energetic grid of a city, can be one of the first indicators that it is becoming smarter? And if yes, in your experience, what are the most recurrent changes that you see when a city is becoming smarter, specifically in mobility?
It is a question. So there is some evolutionary changing. For example, the Prague has a smart city index, and there is some statistics how to change behavior and number of electrical buses and charging stations. So it is some evolution. But I was surprised, for example, during COVID time, how we change our behavior. That also in universities we have classes like this, but during COVID we used Microsoft Teams and we prepared lectures, and now you can see that, or understand that it is not necessary to travel. It is other part of a smart city, how to change behavior of citizens not to travel. And I am from Faculty of Transportation Sciences, but we explain students that for us the best transport is no transport. So it is the contradictory to our profession. But as I showed you, video from Boston. So you must first understand why people travel, what and if you understand it and new technology can help you, then you can think about some measures and some different offer. For example, homework and some virtual classes and something like that and that. And maybe COVID was a difficult time, but help us to change the behavior. And the future, if you will have a limited infrastructure and there will be congestion. I know it from Colombia, in Bogota. People from Bogota say that Bogota is 3 hours from Bogota. So sometimes if there is a traffic jam, it is for 3 hours. So it is a disaster, it is loss of time and loss of energy and economical losses. And we should try to use new technology. We are in 21st century to find solution.
Anyone?
Hi, good afternoon. First, I'd like to say I'm very sorry to both professors because I had a medical appointment, so I couldn't be here at 2. But I would like to introduce, I've been learning a lot since this morning, and I would like to introduce the component of gender. Now, being a woman and thinking of collective transportation, which I really think should be incentivized in Brazil. And thinking, of course, that Brazil is a country full of inequalities. And also thinking of this little sticker that I collected, and it says Feminine Collective at this university. And in Brazil we have some, of course, I'm not a specialist in the issue, but I can think of some examples like in Rio de Janeiro, for example, which is a city that uses train transportation a lot. And there are a lot of people who live in the urban peripheries. And thinking of women, for example, there was a very high rate of abuse in these trains. And one of the measures that was taken was to have separate carriages for female workers so that they would not be abused in trains. So my question would be, could you think of any sort of measures that could make cities smarter for minorities? Thinking, let's say, of countries like, of course, you said you have experience in the US, but if we can think of such measures in countries like Brazil, thinking of inequalities. Thank you.
Because I like examples, because every city is different. And for example, one city that I think it's care for minorities and care for a special group of citizens is Vienna. If you look at the score of best smart cities in the world, many times Vienna is on the first level, and they are not so big technologically oriented like Singapore and others, but they organize the forum for minorities, forum for foreigners, forum for disabled people, and try to systematically work with the minorities. And for me, example of application of new technology was during time of refugees, and Vienna were thousands of refugees from different countries. I visited Vienna during that time, and I was surprised that even very poor people had very good mobile phone with data services. And Vienna authorities started to communicate separately with different minorities, with different group of refugees, and perfectly manage trains and some movement of hundreds and thousands of refugees in the city. So it was example of application smart technologies in such a problem that I did not expect it.
Anyone?
My question is about the green hydrogen. This concept is kind of abstract in my mind. So can you summarize it once again about how this method works and maybe give us some applications here in Brazil?
Thank you. So basically, the hydrogen industry, I would say, it spans for a long time. So basically, you can take, for instance, natural gas, which is CH4, and you break it, and you take out hydrogen, and you can use this hydrogen in many technologies, in many applications. You can even use it as a fertilizer, as ammonia. And the specifics with green hydrogen is that instead of using a fossil fuel like natural gas, you take this H2 out from somewhere else, actually without using fossil fuels. So the main technology in this particular application is using water. You take water, which is H2O, and you take the H2, the hydrogen, by a process called electrolyzer. And this electrolyzer basically uses electric energy that powers up this water, and with these electrical currents, it separates hydrogen from oxygen. And in order for you to call this hydrogen green hydrogen, this electrical power has to come from renewable energies. So actually, Brazil is one of the countries in the world, because we have a lot of renewable installed capacity that has the potential to become a global producer of green hydrogen, because we have a lot of renewable energy that we can use in this electrolyzer procedure to produce hydrogen. And in terms of applications, we have applications, like I said, for ammonia as fertilizer, but you can actually use this hydrogen to power up cars, like I showed you here. You can actually use this hydrogen actually to power up energy plants, power plants as well as energy, so it converts energy again. So actually it's called PTX, power to anything. Once you have hydrogen, you can use it in many applications. You can even power up ships, these large container ships that move throughout the world with green hydrogen. There is big projects coming in Japan, with these long-haul transportation hubs. In Europe, you're looking at pipelines that were used for natural gas. They are being retrofitted so that you can actually use these pipelines to transport green hydrogen throughout them. So basically, that's what green hydrogen is. Yeah.
If I may add that really hydrogen technology is very promising, and it's not so easy to copy for China. It is maybe why Germany invested so many effort into it. And really in Germany there is a city, Hebron, I think, and it is a full hydrogen city. So it is the former coal area, and they transform it to full hydrogen city, and everything like air conditioning and heating and buses and passengers cars and everything is for hydrogen. And there is a set of many research institutes from Japan and for this. So it is the example how the coal area can be transformed into new technology hydrogen area.
We're almost in the end. I leave Lívia for one more question.
Just want to ask you one last question, and is to connect with smart city, so the whole theme, with the transportation. It's basically to see what is your vision or your perspective estimate about autonomous cars. So for us, it's still very, very far from, like, we're far from reach, right? But we know that the technology exists. So basically, do you think we're gonna see in our lifetime, like, happening really happening, or maybe our children of our children? What is your opinion and vision? Both of you. Thank you.
So I had in my slide that there are 5 levels of autonomous cars. So I had no time to explain it in detail, but now we have number 3. It is the Tesla. For example, in America, you can have it in under good condition, weather condition, and so on. You can go on a highway, American highway, without touching or without driving. So it is the reality. Problem starts to be to go to higher level, to 4th. It's a more difficult, and 5th it is non-achievable. And problem is that I don't believe that it will be very soon, because there are a lot of crisis situation and some exceptional situation that the driver is still possible and liable for the driving. But the way to autonomous driving go to better and better assistance services, like in Tesla it is one way, and second way from Google and others that try to design the car completely newly with new procedures to be fully autonomous. But number 3 is a reality. Number 4 is a testated. Number 5 is in 20, 30 years for our children. But also there are the passengers cars. But in Prague we design now the metro number D, and it will be fully autonomous. In airports it's fully autonomous. Trains and so on. So I think that it is the future, and for university it is the chance, because many American university has a small bus, as I showed, as an attraction for students and for people, and it is easy to have such not under real conditions, but on some selected roads to transfer students from one building to another, or in hospitals to disabled people from other side to other. And in Germany I have a lot of videos that they implemented practically this autonomous bus for 6 people between some district where are old people and the first nearest station of S-Bahn. So it was every 15 minutes you can use it, but there was operator inside that has a power to press the red button in case of any emergency. But it never happened, but still the person was there.
Just very quickly, and like Professor Svítek said, Tesla has this technology, and it works pretty fine. I used it. The only thing is that every 4 minutes or so you need to put your hands on the wheel. Otherwise, Tesla will stop. Yeah, they have some equipment that will tell you. So it requires the driver to be there at least. And I agree with Professor Svítek. The problem is liabilities. So in the US, they have had some accidents on the road, basically because the driver wasn't driving at that time, and for some reason the Tesla auto driving system didn't perform well. So I think that the legal part is more complicated. We see small vehicles like Amazon's distribution centers. They use these forklifts, fully automated forklifts that go pick up the cargo. They took it somewhere else. They move it. You don't need anyone to be there. So in controlled settings, it's very easy for you see to these autonomous vehicles working around, like connected within a smarter grid somewhere, like an IA kind of grid. Yeah.
All right, we are concluding this session. I hope everyone had a good time here. Thank you again, professors, for being here. Okay. So I invite all of you to enjoy the coffee break. that should be starting right now. And return at 4 p.m. to the other session of the conference. Thank you.